वेलकम टू द लेक्चर 9। आज हम लोग सोल्यूशन ऑफ लीनियर सिस्टम ऑफ इक्वेशन पार्ट 2 देखेंगे। लेक्चर 8 में हमने सिस्टम्स, उसके टाइप, होमोजीनियस, नॉन होमोजीनियस सिस्टम और नॉन होमोजीनियस सिस्टम में नेचर ऑफ सॉल्यूशन और एवैल्यूएशन ऑफ सॉल्यूशन देखा था। आज हम लोग होमोजीनियस सिस्टम का सॉल्यूशन और एक टॉपिक अपने कोर्स में है एलयू डिकम्पोजिशन मेथड, उसको भी सीखेंगे। Solution of homogeneous linear system of equations. मैंने आपको बताया था कि होमोजेनियस सिस्टम जो आपका है that is in the form of AX equal to null matrix। आप मेरा लेक्चर 8 फॉलो कर सकते हैं इसके लिए, where A is an m cross n coefficient matrix, X is our solution matrix of order n cross 1 solution matrix, and it is an m cross 1 null vector. So if we write in the form of linear equations, this was the representation for homogeneous system, who is representing m equations in n unknowns. In the lecture 8 I have discussed it. So we can write also in the form, actually this is the representation of these equations: a11 x1 plus a12 x2 plus so on a1n xn equal to 0. Now the right side will be 0 because the B matrix is reduced in the form of B matrix is replaced by null matrix, and null matrix is a column vector of order m cross 1. A21 x1 plus a22 x2 plus so on a2n xn equal to 0, and so on am1 x1 plus so on amn xn equal to 0. If we write in the form of coefficient matrix, then A matrix is a11 a12 a1n a21 a22 a2n a m1 a m2 and so on a mn. And if we write the solution matrix, x1 x2 xn is equal to the 0 0 0. It is an m cross n matrix, it is an n cross n matrix, it is a m cross n matrix. And if we replace it by capital A and if we replace it by capital X, and this is your null matrix O. Now the right side is 0. This is a homogeneous representation of linear equations. Now how to check the nature of solution? Nature of solutions. In the lecture 8 I told you a homogeneous system is always consistent. It is always consistent. Means there are two possibilities here: unique solution, infinitely many solution. Unique solution is also called trivial solution, and it is always zero solution, because in this case possible solution is zero solution, so all the solution variables are zero here. Infinitely many solution is called a non-trivial solution. Non-trivial solution also exists here, trivial solution exists In this case also, trivial solution exists in both the cases, but in the case of infinitely many solution, non-trivial solution also exists, or non-zero solution also exists. Zero solution is also solution for infinitely many solution, and non-zero solution also exists. Now, how to check the solution is unique or solutions are infinitely many? So we will use the concept of augmented matrix as I have discussed in lecture 8. Now, if we write augmented matrix A by null matrix O is equal to the A11, A12 and so on, A1n, A21, A22, A2n, AM1, AM2 and so on, AMN, and this is partition is 0, 0, 0. In the case of non-homogeneous, it was the partition of matrix B, but in this case B matrix is null matrix. Now change the matrix A in row echelon form. Using row elementary operations. We can use only row operation due to this unique column. The column is 1, so we cannot use the column operations. Now, same operation we have to apply for the null matrix, but in the case of null matrix, all the entries are 0, so there will be no effect of row elementary operations in this null matrix. Now, if rank of A augmented matrix is equal to rank of A is equal to number of unknowns, then it will be unique solution, or also called trivial solution, and also called zero solution. In this case, all the variable coefficient is equal to the 0, and it is the only solution because it is a unique solution. But if the rank of augmented matrix is equal to rank of A, both the rank will be same here, because this column is not going to put any effect in the rank of augmented matrix. So in this case, both rank will be same. That's why this system is consistent. If the rank of augmented matrix is equal to the rank of A, then system is always consistent. And this column is not going to put any change in the rank of augmented matrix. That's why homogeneous systems are always consistent. Is less than number of unknowns, then infinitely many solutions are here. Non-trivial solution also exists. Means non-zero solution also exists. So this is the way to check the nature of solution of homogeneous linear system of equation. I have one remark also. If A is a square matrix, up to now we are taking rectangular matrix of order m cross n. Now I am considering it a square matrix of order n cross n. Then we have a very easy method to check the nature of solution. then we will be able to find the determinant due to square matrix. If determinant is non-zero, then the system has unique solution or trivial solution or zero solution. And if the determinant is equal to 0, then infinitely many solutions or non-trivial solution also exist. Also exist means trivial is also solution for infinitely many solution, or non-zero solution also exist. एक बात को ध्यान रखिएगा, this remark we cannot use for non-homogeneous. Above remark cannot be used for Ax equal to B means non-homogeneous system and B is not equal to the null vector. Now we have some examples to check the nature and find the solution of linear system of equation. Example 1. Solve the linear system of equation. We can write it in the form of coefficient matrix 1, 1, 1, 2, minus 1, 1, and third is 1, minus 2, 3, and the solution coefficient are x, y, z equal to 0, 0, 0. Right side is 0. Now we can see that if we compare, it is A, it is X matrix, and this is a null matrix. It's a homogeneous system. It's a homogeneous system. Now I'm going to write its augmented matrix. One, 1, 1, 0, 2, minus 1, 1, 1, minus 2, 3, 0, 0. For changing in the row echelon form, we have to make these two into 0 with help of 1. So R2 is replaced by R2 minus 2R1 and R3 is replaced by R3 minus R1. So augmented matrix is equivalent to 1, 1, 1, 0, minus 3, minus 1, 0, 0, minus 3, 2, 0. Now we do not bother about this extra column because all entries are 0. So if we use the row elementary operation in the matrix A, there will be no change in the null vector 0, 0, 0. Now for row echelon form, we have to make this entry also 0. So with the help of this leading entry A22, so R3 is replaced by R3 minus R2. It is 1, 1, 1, 0, minus 3, minus 1, 0, 0, 0, 3, 0. We can see that it is in the form of row echelon form. So we can see the rank of augmented matrix. Rank of augmented matrix is always equal to rank of A in the case of homogeneous. In case of homogeneous. So don't worry about the rank. And we can see that there are 3 non-zero rows, so rank is equal to 3. And the variables, unknown variables are also 3, x, y, z equal to the number of unknowns. So we have unique solution. So the nature of solution is unique. And what is the solution? In the case of unique solution, we know that solution is trivial and trivial solution is zero solution. But I am going to find that trivial solution by using back substitution method. So we can see that this is equivalent to 1, 1, 1, 0 minus 3 minus 1, 0, 0, 3, and this partition was 0, 0, 0. And if we write in the form of xyz, we can write it 1, 1, 1, 0 minus 3 minus 1, 0, 0, 3, xyz equal to 0, 0, 0. And if we multiply this column vector to this coefficient matrix A, we will get x plus y plus z equal to 0, minus 3y minus z equal to 0, and 3z equal to 0. Use back substitution. We will get z equal to 0, and if it's z equal to 0, y will be 0, and if y and z both are 0, then x equal to 0. Hence, this is a solution of this linear system of equation is 0, 0, 0. This is also called zero solution. And this was our trivial solution. This was our trivial solution. And ये हमेशा हमें मिलेगा जब भी हमें यूनिक सॉल्यूशन मिलेगा. So in the case of unique solution, the solution is trivial, and that trivial solution is zero solution. Zero solution. So no need to evaluate in this manner next time. We can, if our rank of A is equal to the number of unknowns, then solution is unique. And if solution is unique, then solution will be trivial in the case of homogeneous system. Please keep it in mind that trivial solution is zero solution. So all the variable will be equal to 0. Next example is solve the linear system of equation. I'm going to write the coefficient matrix 1, 2, 3, 2, 3 minus 2, 4, 7, 4, x, y, z, 0, 0, 0. If we write matrix A, this is our solution matrix X equal to null matrix. So it's again a homogeneous system. If we write in the form of augmented matrix, it is equal to the it is equal to the 1, 2, 3, 2, 3 minus 2, 4, 7, 4, 0, 0, 0. Now change it in the row echelon form. So I'm going to make these entries 0 using the row operation. R2 replaced by R2 minus 2R1, R3 replaced by R3 minus 4R1. So augmented matrix is equivalent to now 1, 2, 3, 0, 0 minus 1 minus 8, 0, 0 minus 1 minus 8, 0. Now I'm going to put this entry 0 for changing the row echelon form. R3 replaced by R3 minus R2. So it is equivalent to 1, 2, 3, 0 minus 1 minus 8, 0, 0, 0, 0, 0. Now we can see that the rank of augmented matrix is equal to the rank of A is equal to the 2, because there are 2 non-zero rows there, and it is less than number of unknowns. Number of unknowns. It means there will be infinitely many solutions, or non-trivial solutions will also exist. Now, this nature of the solution is infinitely many. Now we will evaluate the solution. evaluation of solution. We can see that this is equivalent to 1, 2, 3, 0, minus 1, minus 8, 0, 0, 0, 0, 0, 0. And you can see that if we write in the form of x, y, z, 1, 2, 3, this is equal to 1, 2, 3, 0, minus 1, minus 8, 0, 0, 0, x, y, z equal to 0, 0, 0. The coefficient of x is a11 and a11 is 1 here, non-zero, so it's a leading variable. For the y, if we write is at a22, it is not equal to 0, but the coefficient of z, if we consider a33, it is 0, so it is your free variable. And we can see that this row and this row has non-leading variable, non-leading elements 1 and minus 1, so both are leading rows. Similarly, both the columns are also leading because both the entries are leading here. It means Z is arbitrary variable. Z is arbitrary variable. We can write this system of equation as also x plus 2y plus 3z equal to 0 minus y minus 8z equal to 0, and z is your free variable, so let z is any k, and k can be any real number. That's why for different values of k we will get different solution, and k is any real number and real number is not countable. That's why the solutions are also not countable, hence infinitely many solutions. If z equals to k, it means y will be minus 8k. If we put z equal to k here, and x is equal to 13k. If we put the value of y and z, we can see that x equal to 13k. So solution is x, y, z equal to 13k minus 8k and k. If we take k outside, 13 minus 8 and 1. So if anyone put k equal to 0, we will get 0 solution. This is a trivial solution. It means in the case of infinitely many solutions, trivial solution is also included. We can put k equal to any value. For example, we can put k equal to 1, then the solution will be 13 minus 8, 1. You can check this solution will satisfy these three equations. Anyone can put k equal to 2, anyone can put, then 26 minus 16, 2 will be another solution. So you can see that for the different values of k, we will get different solutions. It means there will be infinitely many solutions because k is not countable here. Next, determine the value of a so that the system of linear equations have non-zero solution. Non-zero solution, it means we are searching for non-trivial solutions. And non-trivial solution हमें कब मिलते हैं? जब हमें infinitely many solution मिलते हैं. Infinitely many solution means we are interested when rank of A is less than number of unknowns. So we can see that this is a homogeneous system because the right side is 0. So we want to make this type of setting here. Now, write its coefficient matrix 2, 1, minus 2, 1, 1, 3, 4, 3, A, X, Y, Z, 0, 0, 0. Now write its augmented matrix 2, 1, minus 2, 0, 113043A0. And for the EG calculations, we want first interval 1, so we can replace R1 by R2. It is not necessary, but for calculation point of view, we can replace it. 1130 2 1 minus 2 0 4 3 8 0. Now change in row echelon form. So these entry must be 0. So R2 is replaced by R2 minus 2R1 and R3 is replaced by R3 minus 4R1. So augmented matrix is equivalent to 113 and no need to bother about column 0 vector. It is 113 0 minus 1 minus 4 0 0 minus 1 a minus 12 0. Now this entry must be 0 with the help of this second leading entry A22. So R3 replaced by R3 minus R2. So augmented matrix is equivalent to now 113 0 1 minus 1 minus 4 0 0 0 a minus 8 0. Non-zero solution means we are searching for infinitely many solutions. So for non-zero solutions, because if the rank is equal to the number of unknowns, we will get a trivial solution. That's trivial solution is unique solution, and also that's zero solution, not non-zero solution. So for non-zero solutions, we have to make the condition of infinitely many solutions. So rank of A is equal to rank of augmented matrix 3 less than number of unknowns. So it will be less than 3. So less than 3 means there will be two possibilities, 1 and 2. But rank is already 2 here because there are 2 non-zero rows. So minimum possible rank is 2 here. So for making the rank 2, we have to put A minus 8 equal to 0. When A will be equal to 8, this row will be entirely 0 and the rank of A and augmented matrix A by O will be 2. In that case, this rank will be less than number of unknowns, so we will get always infinitely many solutions and that have non-zero solutions also. Hence, find the solution. So second part is how to find the solution here. Evaluation of solution. So we reached up to 1 113 0 minus 1 minus 4 0 0 a minus 8 0 0 0. And for having non-zero solution, we put a minus 8 equal to 0. So now it is 113 0 minus 1 minus 4 0 0 0. And if we write in the form of solution matrix x y z equal to 0 0 0. So we can see that this is a leading row and this is another leading row, but this row is not leading due to the symmetry. This is these are leading columns and this is a leading row and this is another leading row, but this row is not leading. Similarly, these first two are leading columns and these first two are leading rows. It means third row and column is not leading. So z is free variable. Z is arbitrary here. Arbitrary variable. So if we write in the form of x plus y plus 3z equal to 0 minus y minus 4z equal to 0 and z is arbitrary, so z equal to k will give you y equal to minus k and then you will get x equal to k. So it will be the solution k comma minus k comma k, and for the different values of k we will get different solutions. For any particular k equal to 1 we will get a non-zero solution. This question can be solved with the help of our remark, that means determinant method also, because A is square matrix here. A is square matrix here. Using remark, but this remark only tells the nature of solution. Nature of solution. We cannot evaluate the solution using this remark. So H A was 2 1 minus 2 1 1 3 4 3 A. It's a square matrix, so we can go by determinant method. For non-zero solutions, means infinitely many solutions, I told you determinant must be equal to 0. So you put determinant equal to 0, you will get A is equal to 8. I am giving you as a homework, you can try it. So by this I am concluding the solution of homogeneous system using rank method. Now I am giving you 2 questions as a homework. You must try. First question. Find the values of k for which 3k minus 8x plus 3y plus 3z equal to 0, 3x plus 3k minus 8y plus 3z equal to 0, 3x plus 3y plus 3k minus 8z equal to 0 have non-trivial solution. Similar problem I have solved. We will get k equal to 2 by 3, 11 by 3, 11 by 3. Question number 2 I am giving you. Find the condition of PQR so that following system has non-trivial solution, and the system is Px plus Qy plus Rz equal to 0, Qx plus Ry plus Pz equal to 0, Rx plus Py plus Qz equal to 0. I am giving you answer here. P plus Q plus R equal to 0 and P equal to Q equal to R. Please verify these conditions. These are 2 important questions based on example 3. Now I'm going to discuss another method in the syllabus of GATE in some branches, that is called LU decomposition or factorization method. LU decomposition or factorization method. It is also in the syllabus of some branches. This method is based on the fact that every square matrix can be factorized into a lower and an upper triangular matrix if all the principal minors of A are non-singular. For a case, if we take a 3 cross 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. All the principal minors are A11, that must be non-zero. For LU decomposition. For LU decomposition, all the principal minor must be non-singular, and second order principal minor A11, A12, A21, A22. This is also non-zero, and so on. We have more second order minors also with respect to A11, with respect to A22, with respect to A33. You can verify. And we have also a third order minor, that's the determinant of this matrix. Obviously, A21, A22, A23, A31, A32, A33. This is also not equal to 0. Then only we can apply LU decomposition method. There are two types of LU decomposition method. Two types of LU decomposition methods. First is Doolittle and second is Crout's. Doolittle decomposition method and Crout's decomposition method. I am going to discuss the theory of Doolittle and one numerical based on Doolittle method, and we will discuss the theory of Crout method, and I will give you two examples as a homework based on Crout's decomposition method. So सीखते हैं इसको. First is Doolittle decomposition method. Consider, I am going to consider for a 3x3 system only. Otherwise, it will be quite difficult to understand. Consider the system of equations. Okay, this method will work for both. Will work for both AX equal to B and AX equal to null vector. It will work for both homogeneous and non-homogeneous, if the conditions of LU decomposition methods are satisfied. That condition is based on the matrix A, that all the principal minor must be non-singular. A11x1 plus A12x2 plus A13x3 equal to B1. A21x1 plus A22x2 plus A23x3 equal to B2. A31x1 plus A32x2 plus A33x3 equal to B3. One important point, A is here a square matrix. A must be here a square matrix. Then only we can apply Doolittle method, because the method will work for any square matrix only. And that square matrix is factorized into a lower triangular matrix and upper triangular matrix. And lower and upper triangular matrix are special types of square matrices. We can see that this system can be written as in the coefficient matrix A11, A12, A13, A21, A22, A23, A31, A32, A33, X1, X2, X3 equal to B1, B2, B3, and this can be supposed as matrix A, this is matrix X, and this is matrix B. So this is a system of AX equal to B. Now, how LU decomposition method works? Let A is equal to L into U, where L is lower triangular matrix and U is upper triangular matrix. Every square matrix can be factorized into a product of a lower and a upper triangular matrix. We will use this concept here. For the case of Doolittle method, they suppose the matrix L is equal to 1, 0, 0, L2, 1. This is a row 2, first column entry L21, 10, L31, L32 and 1. And U is supposed as U11, U12, U13, 0, U22, U23, 0, 0, U3. You can see that this is a lower triangular matrix because all the entries above the principal diagonals are 0, and this is a upper triangular matrix because all the entries below to the principal diagonal entries are 0. Now we are interested in the solution of Ax equal to B. So if we put A equal to L into U, that will be Lux equal to B. And we know that matrix are transitive matrix hold that associativity. It means L into Ux equal to B. If we suppose L into Y equal to B, it means we are supposing here Ux equal to Y. So we have two system of linear equations here. This is called first and this is called second. Firstly, we will solve Ux equal to Y and we will try to find Y, and then we will put Y in the equation 2. We will find the xy, the values of x1, x2, x3. We will firstly we will find Ly equal to B. This is the equation 1 and this is equation 2. Our aim is to find Ax now. So we will find firstly Y and we will put Y in the equation number 2. Now how to find L and U matrices? Firstly we will see this. Evaluation of L and U matrices. We know that L into U is equal to A. Now you put the value of L here. 1 0 0, L21 1 0, L31 L32 1, and U is U11 U12 U13 0 U22 U23 0 0 U33 is equal to the matrix A11 A12 A13 A21 A22 A23 A31 A32 A33. If you multiply this L into U, you will get U11 U12 U13 L21 U11 L21 U12 plus U22 L21 U13 plus U23 L31 U11 L31 U12 plus L32 U23 U22 U22, you will get U22 here. And this is your L31 U13 plus L32 U23 plus U33 is equal to A11 A12 A13 A21 A22 A23 A31 A32 A33. Now you will compare all the 9 entries to the right side and you will get the values of U11, U12, U13, U22, U23, U33, L21, L31, L32. There are 9 unknowns here and you will get 9 equations. Then 9 equations are very easy and you will find the values of all the L's and U's. One important remark I want to add here. One important remark. There is a very small difference between Doolittle and Crout method. So I will discuss that in Crout method also, but I am going to here to write a remark. To produce a unique solution, we are interested in unique solution in this case only. It is convenient to choose either LII equal to 1 or UII equal to 1 for I equal to 1 to 1. Means you can take L11 equal to 1, L22 equal to 1, L33 equal to 1, or U11 equal to 1, U22 equal to 1, U33 equal to 1. I want to tell you this was chosen by Doolittle. You can see in my previous slide. And this was chosen by Crout. So this is the only basic difference between Doolittle and Crout method. Now I'm going to solve one example based on Doolittle method. Solve the following linear system of equation by method of factorization. Now we can write as in the coefficient matrix 1, 3, 8, 1, 4, 3, 1, 3, 4, x, y, z equal to 4 minus 2, 1. This is your A matrix. This is your solution matrix. This is your column vector. We can check that all the leading minors of matrix A are non-zero. It's a homework for you. You can verify it. Now I'm using A equal to LU here. So I told you that the relation between LU and A is, what is LU multiplication? U11, U12, U13. Please see my previous slide. L21, U11, L31, U11. We solve it column wise. Then it will give you easy calculations to you. L21, U12 plus U22. L31, U12 plus L32, U22. And it is your L21, U13 plus U23. This is your L31, U13 plus L32, U23 plus U33 is equal to the matrix A. It means 1, 3, 8, 1, 4, 3, 1, 3, 4. If you compare, you will see that U11 equal to 1. First we go row wise. First row, first column. Row 1, then column 1. See this. Row 1, U12 is equal to 3 and U13 is equal to 8. U12 is equal to 3, U13 is equal to 8. Now go column wise. So L21, U11 equal to 1. U11 you already have 1. It means L21 equal to 1. And L31, U11 equal to 1. U11 you already have 1. It means L31 is equal to 1. Now go row 2. Go row 2. First entry I have already used. L21, U12 plus U22 is equal to 4. You have L21 is 1, U12 is 3 plus U22 equal to 4. You will get U22 equal to 1. Similarly, now row 2, then column 2. Then you will get row 3, column 3. I am going to write all the values. You just try in your home. Minus 5 and L32 equal to 0 and U33 equal to minus 4. So these are the unknowns of L and U. Now we can separate L and U matrices. So what is now L matrix? Now L matrix can be written as 1 0 0. You put the value of L21 now 1 1 0, L31 1, L32 0 1, and you put the values of U11, U12, U13 138 0, U22 1, U23 minus 5 0 0, U33 it is minus. So now you have L and U matrices, and we want to solve the system AX equal to B. So put L equal to L into X equal to B, or L into Ux equal to B. I am going to suppose L into Y equal to B, where U into X is supposed as Y. Now I am going to solve firstly LU equal to Y, LU equal to B, LU equal to B. So 1 0 0, 1 1 0, L Y equal to B. I am going to solve it, where Y is a column vector, Y1, Y2, Y3. I am supposing it Y1, Y2, Y3. 1 0 1, Y1, Y2, Y3, and B is already given to you in the question. It was 4 minus 2 1. Now it's a lower triangular matrix. So using forward substitution method, you can see that Y1, its a product is Y1 plus Y2. You just multiply this matrix to L matrix, L and Y matrix you multiply. Y1 plus Y3 equal to 4 minus 2 1. If you compare, you can see that Y1 equal to 4, Y2 equal to minus, Y1 equal to 4, and Y2 equal to, yeah, there is a correction in this question. It is your plus 2, not minus 2. So it is your plus 2, plus 2. So Y1 plus Y2 is equal to 2. It means Y2 is equal to minus 2. And Y3 is equal to minus 3. So this is the solution of Y column vector, Y1, Y2, Y3, and 4 minus 2, minus 3. Now we will solve Ux equal to Y, and we will get the values of X unknowns. I am going to solve it. Ux equal to Y. What is U? 1 3 8 0 1 minus 5 0 0 minus 4. What is your X? X is unknown, X, Y, Z. I have to evaluate these values only. And Y, we got 4 minus 2 minus 3. Using back substitution now. So X plus 3Y plus 8Z equal to 4. Y minus 5Z equal to minus 2. And minus 4Z equal to minus 3. You can see that Z equal to 3 by 4. Now put Z in the second equation. You will see Y equal to 7 by 4, and if you put Y and Z in the equation 1, X equal to minus 29 by 4. So this is the way to solve the question by LU decomposition. Next I am going to discuss Crout's method. Crout's method. It is also very similar to the Doolittle method. Only change is A is factorized in the LU, where L is supposed as L11, L21, L22, it is 0, 0, 0, L31, L32, L33. Means this column is not supposed 1 here, but in the Doolittle method, this column is supposed 1. Means L11, L22, L33 is supposed to be 1. But here, in the case of U, it is supposed to be 1, 1, 1, 1, 0, 0, 0. There are 3 unknowns in the U vector now, U matrix now, U13, U23. In the previous method, L have 3 unknowns and U have 6 unknowns. In this method, L have 6 unknowns and U have 3 unknowns. So similar way, you can find the L and U matrices by multiplying LU and comparing with A matrix. You can factorize matrix A in upper triangular and lower triangular matrix. So same method will work for the Crout method also. Now I am giving you two questions as your exercise. Solve by Crout methods to the following linear equations. X plus y plus z equal to 3, 2x minus y plus 3z equal to 16, 3x plus y minus z equal to minus 3. I am going to write the solution. X equal to 1, y equal to minus 2, and z equal to 4. So that LU decomposition method fails to solve the following system of equations: x plus y minus z equal to 2, 2x plus 2y plus 5z equal to minus 3, 3x plus 2y minus 3z equal to 6, whose exact solution is 1, 0, minus 1. Why this will fail? Because the pivot elements, what is the pivot elements? First, non-zero entry of any row or column. L22 is 0 in the case of Crout method. If you use Crout method, L22 is equal to 0. And if you apply Doolittle method, U22 is 0. So that's why these entries, pivot elements are going to be 0. So we can't apply LU decomposition. We can't apply decomposition. So for applying the LU decomposition method, every square matrix has non-zero, non-singular principal minus, and second, if you break in the L and U, pivot elements, means diagonal elements, principal diagonal elements must not be 0, must not be vanished. So by this, I am concluding this lecture. In the next lecture 10, we will see the problem session based on these lecture 8 and 9. Some previous year question based on ESE and GATE I will discuss. Okay, thank you.